Now in Part 3, we will see how Lucy and Isaac learn about investing in an approach that addresses these challenges and allows multiple applications to exchange data. The software development team explains that the solution is standards and interoperability. First, they show Lucy and Isaac what standards are, and then they explain to them how it will help with interoperability. What are standards? In software, standards are a set of rules that allow information to be shared in a uniform and consistent manner across any application. They are approved and published by an authoritative official organization. As the systems are currently configured for Lucy and Isaac's immunization campaign, OpenLMIS and DHIS2 cannot currently communicate with each other. Remember, DHIS2 has been trying to ask OpenLMIS a simple question: how many DPT vaccines are at Mbaye Clinic this month? But they cannot understand each other without a common set of standards. The software development team instructs Lucy and Isaac on the importance of two specific types of standards to enable interoperability: semantic and syntactic. Standards that help applications establish a common vocabulary are known as semantic standards. For the two applications Lucy and Isaac are using in their immunization campaign, they need to agree on two vocabulary lists in order for the applications to communicate, one for the vaccines and one for facilities. For example, the semantic standard to refer to the DPT vaccine is vax.dpt, and for the Mbaye Health Facility is Facility 145. Once they agree on a semantic standard, they both use the same terms to describe the same commodity. When DHIS2 asks OpenLMIS, how many vax.dpt vaccines are at Facility 145 this month, OpenLMIS responds to DHIS2 with a question: what do you want to know about vax.dpt and Facility 145? With semantic standards, even though both applications are now using the same words, OpenLMIS still doesn't understand what is being asked. OpenLMIS can understand the vocabulary of vax.dpt and Facility 145, but not how they relate. Knowing what the terms mean isn't enough. So the software development team explained to Lucy and Isaac that these applications also need to have common grammar to communicate meaning. Standards that do this are known as syntactic standards. They help you determine how the words fit together. The software development team shows Lucy and Isaac what happens when they have both semantic and syntactic standards. With both sets of standards in place, the DHIS2 and OpenLMIS applications can share data automatically and seamlessly. So when DHIS2 asks OpenLMIS how many vax.dpt vaccines there are at Facility 145, OpenLMIS can provide DHIS2 with that data, responding that there are 5 vax.dpt vaccines at Facility 145. Now that Isaac and Lucy understand standards, they must determine all the different semantic and syntactic standards they would like to adopt in ONESA. The software development team explains that investing in standards will make it easier and more cost-efficient to enable interoperability between all their digital health applications. Interoperability is the ability of multiple applications to communicate with one another by accessing, exchanging, and making use of data in a coordinated manner to achieve health goals. To ensure true interoperability at a large scale between all their systems, Lucy and Isaac learned that they need to invest in a component known as a Health Information Exchange. A Health Information Exchange, or HIE, is part of a country's enterprise architecture that connects multiple applications and allows them to move data between one another using standards bundled together to provide implementation guidance for the software developers. This approach overcomes the quadratic cost problem. OpenHIE is an example of such an architecture. One of the things that HIEs do is store lists of terms and concepts, mapping how these lists relate to each other across different applications. Standards make this mapping process easier. The HIE receives the data from each of our applications and keeps track of how they relate and will translate between the different applications in real time. This enables the 3 or more applications to communicate through our HIE as a central translator. Now, any new application that gets added only needs to be able to communicate with the HIE. And if an application changes, only the HIE needs to be updated, while all the other applications can still communicate. This is one way to keep costs down and avoid the quadratic cost problem we saw in Part 2. Now that Isaac and Lucy understand how standards let applications communicate, both vocabulary and grammar, and that an HIE lets many applications easily exchange data in a cost-effective way, they want to invest in building one, and are ready to learn more about how the components of an HIE architecture can interact with their applications. Once they know this, they can work with the MOH's Digital Health Lead to ensure that the investment roadmap for their national HIE will meet their needs. The next year, when Isaac and Lucy need to do their planning, they can pull the data they need from the different systems together. This lets them see how many children need to be vaccinated, how many vaccines they have available, and how many they need to order. With their applications linked, Isaac and Lucy can ensure that all the children in their district and country are vaccinated and can grow up healthy. Moreover, by using an HIE to help interoperate their applications, data is showing them population-level trends they couldn't see before, and now they can make time-sensitive, evidence-based decisions that impact the lives in every district, at every age group, and at each point of the health journey.